Welcome back to Tutoring with Abdul, to another class of digital electronics. In today's session, we'll be talking about number system that we use in digital electronics. So before we do talk about that, we should know what a number system is. If it is in digital electronics or it is a mathematics number system like a decimal number system. So what is that? A number system is a code that uses symbols to represent a number or something. It's a code. It's just a code. For example, 3 as a decimal number, 3 base 2 as a binary number there, but that doesn't exist as just a number. Let me correct that mistake right away. Let's say 8 base 8, and for example, say 120, anything that represents something, a number, or anything that will be a number system. So a number system is a code that we use. A number system is a code that uses symbols, such as any symbol that you think of as a numbers, to represent a number or something that you think of. For example, there's 3 apples. 3 apples. So that's 3 is the number. Apple is just a unit. 3 here represent the quantity of apples, correct? So that's how we say the number system. The decimal system uses 0 to 9. We studied that in another mathematics classes. If you have problem, or if you encounter problem using decimal numbers, please go ahead and in my math tutorial playlist, or there's a video of decimal numbers. It's a three part on decimal number system. That will help you. So don't hesitate to go and check that one. Thank you. So it's the decimal number we use is let's start from 0 to 9, and everything else is repeated. For example, 110 and anything like it's still, because they use same symbols. 110, they are repeated. And why we call it decimal? Because 10 is deci. That's what that word come from, deci. Okay, I said if you have problem, then go please check on my YouTube channel. Now we're going to the fun part of this lecture here. Binary number system. What is a binary number system? As we think of the number, the word of binary, that means only 2 things, like a number system that uses 1 or 0. Only 2 options, so it goes both 0 or 1. That's 2 options. The number system that only uses 1 or 0. So that's called binary number system. It's been widely used in electronics. Just say it is the computer language. Electronics only understand binary language. That being said, we only under the electronics or the computer language or anything that's digitally think, they will talk in this language. It'll be either 001 or 0110, whatever. So it'll be binary coding. They'll be talking in that language. So that is the computer's language, actually. Place value, we set up in the math classes. For example, if you have to do this thing, if you have to write down 123, this 100, that can be write down like this: 100 plus 20 plus 3. So each place, this is a 100's place, this is a 20's place, this is the 3 place. That's how we say placing value. We can, I said exact same example right there. This process is called placing value. This is useful for in the next couple sessions, because we will be talking about conversion between binary and decimals. So it'll be good to understand this process here. So this process is called as a placing values, because you place every value. For example, 123, it has three different numbers to it, like 100 and 120 and 3. You can place them separately. That's called the placing value. Okay, now in the binary thing, we have something similar in the binary system, but it's written as a, it start from the right. Okay, that's the right side. I think I said, what is that? So right side here, so it'll be 1s, 2s, 3, 4s, 8s, 16s. Since it's binary, it's multiply by 2. So it'll be 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that will be going all the way to the right side, left side, from right to the left. The reason it's a multiple of 2, because binary system. Okay, that will keep going on to the left side depending on the size of the data or a number. Okay, the numbers between decimals and binary. So it start from, we say like the decimal start from 0 and goes to 9. And these are the code actually, not the symbols, I would say. Okay, the symbols start from 0 to 9. And the binary system, if you represent these numbers 0 to 9, it's be like 0 is 0, 1 is 1, 2 is 1 0, 3 is 1 1, 4 is 1 0 0, 5 is 1 0 1, 6 is 1 1 0, 7 is 3 ones, 8 is 1 0 0 0, 9 is 1 0 0 1. We got these from this chart right here, from this placing value. And this 0 can be written as, since it's a binary, we can have it like, hey, it can be written as a 0 0 0 0, and that should be 1 can be written as a 0 0 0 1. We'll come to that, don't sweat it out. So this is just a chart conversion between this binary and decimals. So how did we get to this table? So yeah, this is a good idea. Placing values helps us a lot in binary system, which I said earlier. In the following box, the top row is binary point and the bottom row is a decimal. So let's say, for example, if you have a number that says like okay, no, never mind that. So 1s is 2 to the 0, 2s is 2 to the 1, 4s is 2 to the 2. You just now the power is again this is multiplied by 2, but you're getting the same power. This number is getting from here. 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, and it's up 2 to the 8 is 512s. So that's how we figure these things out, like from binary. This is the conversion table between these two. We'll talk that later. Yes. So since we talk about the exponents here, if you do have a problem with the exponents, and there's a video of me talking about exponent and power in the math tutorial video, a playlist, please go and check that one too. It will help you a lot. So what does that mean? Okay, so I explained this one. 2 to the power 3 mean 2 times 2 times 2. 2 is multiplied by itself 3 times, that's 8. But base here is base is 2. I'm talking about the math, not the binary base here. The base is 2 and the power is 3, so it means multiply by itself 3 times. That's just a recap from the math class. Now number conversion. So how we convert from decimal to binary and binary to decimals. When working with electronics, especially digital electronics, we might have to convert from decimals to binary and the other way as well. So the other way will be binary to decimals. So let's talk about binary to decimals first. It's not that difficult. Yes, it is not difficult once we learn it. Any given number in binary system, write its place value and write the whole binary number below it. Then wherever you see 1, find its value and write it down. Do such until you have done with the given number. Let's do an example. Okay, so for example, it says like, convert that's 110 to as a to decimal, or write it down as a decimal. So you have to, if it is convenient for you, write down the placing value first. So 2 to the 5, 2 to the 4, 2 to the 3, 2 to the 1, 2 to the 0. That's your decimals. To convert it to decimal number, you gotta write down this table right there, because this is your 1s, 2s, 4s, 8s, 16s, 32s. So this is your binary column, and this is your decimal column. No, sorry, this is your decimal row, and this is your binary row. But we need to deal with the decimal, so we will have to write down our number below these numbers. So how we will do, as we said, any given number in binary system, write it as a place value. So write down the whole place value. So see like how many numbers you have. You have 6 numbers. Write down 1, 2, 3, 4, 5, 6. 6 digit of placing values. Then place each number below this placing value, starting from the right. And then you assign every one that you have. If you, for example, 1 is below this one, or start from, then you gotta, then you start, the counting should be start from the left side. If you have 1 right here, then 35, so 1 to the 2 to the 5 is 32. And if you have 1 right here, for example, that will be 32 plus 16. And if you have 1 right here, the 32 plus 16 plus 4. And if you have it right here, it will be plus 2. If you don't have anything, you don't add anything. So let's do that example, 110, 110. Okay, so we write down this placing value here. Now we will add any one, anywhere you see 1, that value we will be adding to the next number that you see. So that will be in the first value, the first one that you see here is 1. And it's 2 to the power 5, to the exponent 5 will be 32. The second one you see is 2 to the 4 is 16. And the third one you see there is no 1 here, so there is 1 right here. 2 to the 2, it's right there. And then you see 1 in there, 2 to the 1 you see right there. So then you add all these numbers together. So how will you do it? You add them. Where did I add it? So you add it like that. 32 plus 16 plus 4 plus 2. Okay, 2 plus 6 is 8. 8 and 6 will be 12. 12 and 2 will be 14. It will be 1 and 3, 4, 4 and 1, 5. So it will be 54 base 10. Or 54. No, we don't write base 10 because it's very common that we use it everywhere. Since we are converting here, so we should have, because we don't want to confuse that with an octal number or a hexa. So yes, this is right there. 54 base 10 is equal to 110, 110 base 2, or binary number. So that's how we convert it. Okay, or you can do it as follows. Yes, I did it as follows. So 54 base 10. So write it down like that. 110, 110. Every number that represents the placing value, and you have 1 there, add that 1. Add that number. 2 to the 5 is 32, so 32. And everywhere you see 1, 2 to the 4 is 16. Then you got that one. You have nothing in here. You don't do that. You don't add that, or you add 0 there. Then you got 1 right here. 2 to the 2. 2 to the power 2 will be 4. And same thing right here. And that will add up to 54. Okay. Hope this example is clear. If not, we will work a couple more example here. It says like write 111011 as decimals. So first of all, you have to find how many digits you have. You have 6 digits, so you probably have to go from here. You can do it this way. Start from the right to the left. Okay. So it'll be 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to 4, to 5. So you got 6-digit dial. That's all I need. Now you write down that one, or you can even write it down as this. Okay, so that will be 2 to the 0 is 1, 2, 4, 8, 16, 32. So you have 1 right here, 1 right there, 1 right there, 0 right there, 1 there, and 1 there. Everywhere you see 1, you add that corresponding number of that placing value. So that's 1 right there will be 32, plus you got 1 right there, that's 16. You got 1 right there, that's 8. You have nothing in there, you can add 0, that doesn't matter. You have 1 right there, that will be 2. You got 1 right there, you can add that one also. So now you have to add these things. 1, 2, 3. 1 plus 2 is 3, 3 plus 8 is 11, 11 plus 6 is 17, 17 and 2 is 19. 19, 1 will go right there, so it'll be 2 and 3, 5. 59 base 10. So let's do a 48 plus 8. That was 32 plus 16 is 48. It'll be 54. That's 56, 58, 59. Okay, that's correct. So 1, 1, 1, 0, 1, 1. There is one more 1, 1. Okay, yeah. Is equal to 59 base 10. That's how we do that. We write down the placing values, or you can write it down as this way or this way. Wherever you see 1s, and you add that corresponding number to the one that you see the next numbers. For example, if this number was supposed to be 100000 binary number, which is what number is that, right? Okay, so you got 6 digits still, so that number will be 32 as a decimal number, because you only have 1 right there. You probably only have 1 here. It'll be 0 all over the place, so 32 will be your answer. So hope you figured that out. It's not that hard, you just have to practice a little bit. All right, let's do a couple more examples here. Write 111, that with big number right there, to as decimal. Let's do that. I need some space here. That's good. Okay, now write down the placing value. So we say like the placing value will be, we start from 1, 2, 4. Before you do placing value, count these numbers: 1, 2, 3, 4, 5, 6, 7, 8. Now we have to go 8 digits there. 8, 16, 32, 64, and 128. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Once you write down the placing value, or you can do it this way, I'll just write it down in a different color. It's a matter of what color which way you like it. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to 6, 2 to 7. Okay, once you do that, then you write down the numbers, binary number below, starting from the left. Be 1, 1, 1, 1, 4 ones, 5 fifth one, 6, I think it's 9 actually. 1 2 3 4 5 6 7 8. Then I messed up here. Let's write this. Okay, I got 1, I got second one, I got third one, I got fourth one, I got fifth one, got 0 right there, I got that one, and I got that one. Okay, the next step is to find out where your ones are. You can add them, add those numbers. The first number is right there, so it'll be 128. Let's use another color here. Use this favorite. 128 plus, where's the next one? Right there in 64 column. Now the next number is at 32. The next number is 16. The next is 8. You can skip 0. That's why I said like add the ones where you end ones are, because adding 0 will not mean nothing. You can add 0, but I will just save some space. It'll be 2, 1. Add these all numbers together and see what we get. Pause this video and see what number you guys get. I got 251. No, that is like that. 251 base 10. Okay, so hopefully you guys got the same thing, but we can add it together. 1 plus 2 is 3, 3, 8 is 11, 11 and 6 is 17. It'll be a 19, 19 and 4 is 23, 23 and 8 will be 31. So 3 will go up there. So 3 and 1 will be 4, 4 and 3 will be 7. 7 and 6 will be 13, 13 and 2 will be 15, 5, 1 will go right there. So 1 and 1 will go to 251. That is correct, so it adds up. Okay, so that will be 1. Oh, that's an eraser, we don't need that now. 1 1 1 1 1 0 1 1 is equal to 251 decimal base 10. Okay, that was a little bit longer example. Now let's go to the example number 4. Okay, the example number 4 here is a same kind of example, but we will have to convert that number to decimal system. Okay, solution. So first find the placing value, and for that you have to count the numbers. 1 2 3 4 5 6 7 8 9 10. We got 10 digits there, so our value will be going to tens. So okay, so it'll be 2 to the 0, 2 to the 1, 2 to the 3, sorry, that's 2 to the 2. Why did I jump? 2 to the 2, 3, 4, 5, 6, 7, 8. I think that will be good because I got 9 digits there. The last one is 0. 0 doesn't count, but you can add it. 2 to the 9, because the reason I was saying 2 to the 8 will be okay, because 0, it will stop right there, because adding 0 will not mean anything, but I'll write it down anyway. You found the placing value, then you write down those numbers below it. So there'll be 0, start from the left, 1 0 1 0. So we got that 0, we got that 1, we got that 0, we got that 1, we got that 0. No, that 1. Yes. And now we have this one. We'll go in there. And this 0, that's right there. This one, this guy, this one, this guy, the 0. Let's find them. Okay, now the third step is to find where the ones are and you add them up. Yes, so that's why it's like this was an extra, because the last zero, we could simply find 9 digits there. So now wherever you see one, add that value right to the next value here, you see. So 2 to the power 8 is, I think, 264, but I'm not sure. I can't say that, but we will find out. 2 to the power 8 is 256 actually, yes. So that will be 256 is the first one right there. We can't, there's 0 to the, we have anything. That means 1 multiplied by this number, 1 multiplied to, will be 1 times 256. That's what we got. 0 times 7 is 0, so we can't add that. 1 times 2 to the 6, 2 to the 6 is what? 64. It will be 1 time 2 to the 6 is 64. Let's write it down like that. Plus, there is nothing in there, so that's 0. Now 1 times 2 to the 4 is 16. Now this is 0 again. 1 times 2 to the 4, 2 to the 2 is 4. Okay. And then plus 1 times 2 to the 1 is 2. You add these numbers together. So that will be 200. You multiply, you simplify the multiplication step. 256 plus 64 plus 16. Because 1 multiplied by any number will be the number that you multiplying 1 by. So that's 4. That is 2. Okay, so 256 plus 64 plus 16 plus 4 plus 2 will give me 342 base 10. Okay, so the number was 0 1 0 1 0 1 0 1 1 0. Binary number is equal to 342 base 10. Okay, so using an iPad programmer calculator, we have to convert that binary number to decimal. So we will simply enter those number. When we're dealing with a binary or programmer calculator, we only see these 1 and 0 are light up. Every other number is gray, so it's not working even if I push it. I'm pushing 8 and 9 right now, it doesn't work. But if I push 1, it does work. So let me clear that. So our number was 0 1 0 1 0 1 0 1 1 0. So that is our number. The reason that the first 0 doesn't count, because we cannot add that 0. I mean, we can add, but it doesn't affect anything. It's actually 0 1 0 1 0 1 1 0. There should be 0 in the very left side, but the calculator will eliminate that 0 because it doesn't get any value from there, so it will just not count that 0. It will not display that 0 to us because it's useless for the calculators. So in the previous example, we had this binary number, and our the decimal point we got 342. Okay, so we use how can we use the binary to decimal calculator on a computer? So click on the binary and you will see the 1 and 0 option. Uh, if you want to convert 1 0 1 0 to decimal number, since you have 4 digits here, so your placing value will be 2 to the 0, 2 to the 1, 2 to the 2, 0 1 2 and 3. So it'll be 2 to the 3. So wherever you see 1, you add that, you multiply that number to the placing value. So 1 multiplied by 2 to the 3 is 8. And then the next one is plus 1 multiplied 2 to the 1 is 2. So 8 plus 2 is 10. And that's where you will see your answer 10, a decimal number 10.
Okay, see you guys next time. Hopefully these things were helpful. Uh, Please practice. Take care.